quiz that we take on, do I see you Monday?
Yes.
All right, the quiz we do on Monday will be over what we just practiced, okay? So
Just
this is
this?
what we need to know.
I'm so sorry. No way.
You really screamed that out loud.
Okay. All right, here we go. Letter A. Now, I would suggest, these are all just, I'm gonna type in and get the answer problems. I'm gonna round off here, right? That's where I'm rounding off, right here. And some of these are in degrees and some of them are in radians. So I always, you do whatever you want, but I always, however my calculator said, it's in degrees right now, so I'm gonna do all the degree problems. Then I'll switch it and go do all the radian problems. Otherwise, you're gonna be switching back and forth, which is fine. I just don't like to do that. So I'm in degrees, so the first degree problem is B. So cosine 11 second angle degrees, 19 second angle minutes, and then 14 alpha plus. And did you get, this is B, 0.9805? Perfect. Next one, ooh, there's only one more of this degrees, and that's E. Right? E's a degree. So, cosecant. How do I do cosecant? 1 divided by sine. I literally type those buttons. 1 divided by sine. 258 second angle degrees. 19 second angle minutes. And 32 alpha plus.
Oh, you press
I got, this is E. I got negative 1.0211. Is that what you got? Perfect. Now I'm going to change my calculator into radian mode. Sine 3.4, can't miss on that one. Negative 0.2555. Right? And tangent 5 pi divided by 7, negative 1.2540. Is everybody okay? How do I do secant? 1 divided by cosine, 0.83, 1.4818. And how do I do cotangent?
1 over tangent.
1 over tangent. So 1 divided by tangent, 43 pi divided by 19.9206. You okay with that? All right, now. I have optional, this is completely optional. I have a recap assignment and I worked it out with the answers. Now, I prepared this when I was subbing in physics. I was listening to some extraneous conversations that were taking place, and I was a bit distracted from time to time. So I'm not going to guarantee that all my answers are correct. But I've taken a shot at it, and this is completely optional. You have a weekend, if you want to work on it, you can. If you don't want to work on it, recycle the paper. Okay? Now, if I catch anybody working on this during class, though, I'm going to get really mad, all right, and rewrite the quiz. This is not something to do right now. Right now, this is put aside. We have got to get back focused on continuing our march through chapter 4. We have a lot more to go. Mr. Shaddy and I would love to get done with it before exams. so we don't split the chapter. So we need to keep going, we'll see how far we can get. All right, so you recall, we are ready for y equals negative sine 1/2 x. And we had already graphed the regular sine curve, which comes right off the unit circle. Technically, I only need one period of it. This is enough. This is one hill and one valley. But I also went this way just so you could get a sense of the fact that it does go in both directions. So I went once around the circle positive and once around the circle negative, and that was our regular sine curve. Now, we'd also done B. What happened in B? Well, I inserted some numbers. And what happened when I inserted those numbers? Well, the vertical got stretched, but the horizontal got shrunk, didn't it? The two does different things depending on where it is in the equation. So this multiplies the vertical, and this divides the horizontal. So a way for you to think about that, this always confuses people. Nobody ever has trouble with this. But a way you can think about this is like this. We are graphing one revolution around the circle. Would you agree with that? And a revolution is from 0 to 2 pi in radians. So we want to graph that angle in one revolution. Well, if 2x lies between 0 and 2 pi, where does x lie? Between 0 and pi, which is exactly what happened when we graphed it. We cut everything in half, and it ended here. So it ended up having some shape. Oh, no. It ended up having a shape that looked like this, because it got stretched vertically but shrunk horizontally, because now one revolution is only half a revolution because we got 2 in there. So what's going to happen with this guy? Well, what is the negative going to do?
Flip it over the x.
Going to turn it upside down. All right, I'm going to change that. I'm still going to start there, but now I'm going to go down first. What is that? Well, there's no number there, so what does that tell me about my amplitude? The height of my curves is still going to be 1. A normal height, like the black. What does this do?
Multiply the x by
It
2.
divides the width, but since it's a 1/2, it's actually going to multiply by 2. So that means that my curve is going to have to go, let's see, here's 3 pi, 4 pi. My curve is going to have to go all the way to 4 pi. Would you agree with that? So here I go, upside down. Amplitude is 1. So there's the valley. And there's the hill. So it has a height. It's hard when it's all on one graph, I get that. But the point of the exercise is for you to see it's the same shape. We're just messing with it. Okay, we talked about amplitude and period. So the amplitude and period of the regular cosine, regular sine, amplitude and period, amplitude is 1, period's 2 pi. The purple curve, amplitude is 2 and period is pi. A pink curve, amplitude is 1 and period is 4 pi. We didn't do that with sines and cosines before, but kids, we talked about all these changes before. We did them with weird shapes that I made, remember? but, we did all that before. So now we're ready to start sketching some crazy things. So let's see if we can sketch 4 sine 2/3 x. Now you only need to sketch one period. Well, this doesn't even say sketch, but we're gonna sketch it. You only need to sketch one period of this. Okay, so that means one hill and one valley. How you do that, that's up to you. I just like to start at the origin and sketch one hill and one valley and be done with it. What do I know about this curve? What is its amplitude?
4.
4. So it's gonna go up to 4 and down to -4. What do I know about its period? Well, this number is not the period. What is the normal period? No, normal period, 2 pi. The normal period is 2 pi. So if I do just a regular sine, it would be 2 pi. What does this number do to the period?
Multiply by
2 pi divided by 2/3, which is gonna be 2 pi times 3/2, which is gonna be 3 pi. So that means that my hill and my valley get done in 3 pi. Does that make sense to you? Right there. That makes sense? Now, if the whole shebang is 3 pi, what would be this halfway mark?
1.5 pi.
1.5 pi or 3 pi over 2. I normally just leave them as fractions, but you can use decimals if that's easier for you. Does that make sense to everybody? Now, this guy is the halfway point, that's the peak, the maximum, is the halfway point of this. Would you agree that the middle of the hill? So what would that be?
3 pi over 4.
3 pi over 4. And this guy is the middle of the valley. What would he be?
3 pi over 3. No, that was so wrong.
Okay, let me give you a little hint. Let me give you a little hint. This is 3/4. This is 6/4. This is gonna be 9/4 because this is 12/4. Everything is evenly spaced. These are the quadrants of the circle. So they're evenly spaced. They started out being pi over 2, but we made some changes, so now they're 3 pi over 4. But each one of them is the same. That's your picture. That's all there is to it. You just sketched it. Beautiful. What's the amplitude? Already wrote that down. Already wrote the period. The only thing left is frequency. What is frequency? Frequency is the reciprocal of the period. Now I'm going to explain how that works to you in a minute. But frequency is the reciprocal of the period. So if your period was 3 pi, 1 over 3 pi. Now please be careful how you write that. That pi needs to be in the bottom of the fraction. It's 1 over 3 pi. Okay? Now I'm going to explain to you what frequency means here in a minute, but I want to get this other problem done. Anybody have a question about that? I'm going to define frequency for you here in a minute. Okay, let's graph this last one. -2 cosine 5x. -2 cosine 5x.
Okay.
All right, so here we go. Now again, I just like to graph 0 to 2 pi. What would normally be 0 to 2 pi once around? With cosine, that's a little bit funky looking because remember, cosine starts up here. So if you graph that part of it, that's going to be your shape. Do you see that? The hill's going to be split. Some people prefer to start back here somewhere That's completely up to you. That's what I'll graph. The period from normally 0 to 2 pi. So I'm gonna have that shape, but what? What does that negative mean?
Flips it over
It's
to
gonna
X.
be upside down. So now I'm gonna have this shape right here. Would you agree with that? Imagine this thing continued. Do you see the cosine, the negative cosine in there now if I do that? Now, a valley and a hill are a period. So the period actually ends right there. We got half a valley here and the other half here. So that would normally be 2 pi. But I've changed that, haven't I? What have I done?
Divided by 5.
Divided by 5. So now this is 2 pi over 5. My picture is very deceptive because really this thing has been scrunched big time, right? It's a fifth of what it was originally. This is the center. Think about that. Does that make sense to you that that's the center? So what will the center or the midpoint be
Pi
if
over
it
5.
ends at 2 pi over 5?
Pi over
Pi
5.
over 5. And then this 0, where it crosses the x-axis, is the halfway point here. So what would that be?
Pi over 10.
Pi over 10. Now don't freak out, that's 1/10, that's
2/10.
2/10. So this one's gonna be 3/10, which is also the midpoint of 1/5 and 2/5. Remember, you add them and divide by 2 or multiply by a half. So either way, you can use midpoint or just kind of your common sense here. That's 3 pi over 10. My amplitude is 2. And there we go, we've drawn it. So listing out what they want, your amplitude is 2, your period is what?
3 pi
2
over
pi
5.
over 5. And then your frequency would be 5 over 2 pi. And make sure, some of you girls especially, get this pi up a little bit too high. No. Don't be writing things sideways like this. Nobody can tell what you're talking about. 5 over 2 pi. Okay? Now, quickly, in 2 minutes, what's frequency? Let me draw a couple of sine curves for you.
Is it tender? So it's gonna be like all over. Yeah, I think you're really trying to was.
Here's one sine curve. Here's another one.
Actually, maybe it's like an if it takes a minute to show. Try to put the right light.
Okay? Now these are both sine curves, regular sine curves. What's the period of this sine curve?
2.
No, the period is
2.
2. What is the period of this sine curve?
1.
1. Oh, shoot, bad example. Let me make this 1/4, 1/2, 3/4. Now the period's a half, right? Better example. Frequency is defined as the number of periods that get done in 1 unit. So if I look at this picture, this is 1 unit, agreed? How many periods get done? 2. So the frequency is 2. Frequency is the number of periods that get done in 1 unit. Okay, up here, here's a unit. How many periods get done?
1/2.
1/2. That's what frequency is. Okay, got it? All right, quiz next time.